Okay, this is the third video of this series. We've talked about volume and surface area of spheres. Second video had volume and surface area of hemispheres, and then we talked about how to solve to work backwards. If you're given the volume or surface area, how you solve for the radius. This is just going to be a few advanced problems, miscellaneous problems to help us round out the notes and to kind of be well-rounded, do some things like composite shapes and a little more advanced stuff. So here's what we're going to do. Let's find the volume of this shape. Let's find the surface area of this shape. Okay? The volume is pretty simple. It's easy to overthink it, but what I see is that I have a half of a sphere here and another half of a sphere here, and they're the same sphere because they're both 6 for the radius, right? So what I could do is just, you know what, I'm going to move these, I'm going to rearrange my shape, I'm going to put the two ends together and form a full sphere with a radius of 6. So whenever I go to do the volume of this shape, I have a full 4/3 pi r cubed for the round parts. Then I have the cylindrical piece in the middle. And if you remember from our notes on cylinders and stuff, what I have here for this is pi r squared for a base, a circular base, pi r squared, times the thickness of that circle, which is 10 units. So I'm going to have pi r squared times 10 for the thickness, the height of the cylinder. All right, so now it's time to just put in the r. The r value is 6 here, right? So I have 4/3 pi times 6 cubed. Notice it's cubed, right? Plus pi times 6 squared times 10. We just need to be careful and take our sweet time as we do order of operations here. Here's what I know is that 6 raised to the third power is 216. So I'm going to do this here first. 4/3 pi times 216 plus, this one's a little bit easier, 6 squared is 36. 36 times 10 is 360, so I have 360 pi's. I'm going to go ahead and do that in one step right there. Now I need to figure out what in the heck this is, so I'm going to combine the 4/3 into 216. Are you kidding me? Okay. Sorry, a little bit annoyed that we're still doing announcements 45 minutes after school ended. Okay. 4/3 of 216, I need to do that, so I have 4/3. I'm going to multiply that times 216. I get 288. So that first number is just 288 pi's. I have 360 pi's for the cylinder. That's a grand total of how many pi's? 648 pi's. I should probably throw some dimensions in. Let's say that this is inches. There we go. This is all in inches. That means this is in cubic inches. Surface area, a little bit trickier. If I wanted to find the surface area of the shape, here's what I know. I have a half of a surface here, a half of a curved surface here. And this is why it's important to go back and say, you know what, we had this formula for surface area of a sphere, and we said it was 3 pi r squared, right? This is from a previous video. But the problem is, where did I get that? Well, I got 2 pi r squareds from the curved surface, and then because this bottom area, this circular base, is exposed to air, I get an extra pi r squared. That's my third one, right? Well, as I go look at this composite shape, see that circular base is not exposed to air anymore. It's not external. So I'm only going to care about the exposed curved surfaces on the left and the right, and the wraparound portion of the cylinder. So I have 3 surfaces that I need to worry about. Well, lucky for us, that because the middle no longer counts, I could really just take those 2 curved surfaces and I could put them together, and I can make one 4 pi r squared surface area, right? One complete sphere. So, surface area, 4 pi r squared. This will take care of the left and the right ends. Plus, I have that cylinder wraparound that I need to take care of. And this is where it's helpful to know that the cylinder wraparound, I take the circumference of the circle here. The radius is 6. The radius of this circle is 6 right there. So the diameter is 12. That means the circumference is 12 pi. And the height of that thing, of that wrap, is 10 units. Circumference times height for the cylindrical wrap. So now we go and we need to put the radius of the circle in. That's 6. 6 squared is 36. I'm going to go ahead and do this. 12 times 10 is 120. On my calculator, I'm going to do 4 times 36, and I get 144. So it's 144 pi's for the sphere part, on 120 pi's for the cylinder wraparound part. I add those together, and I'm up to 264 pi square centimeters for the surface area. All right, almost done. 2 problems left. The problems that you'll see that'll give you the most trouble are ones where I give you a volume or a surface area and I ask you to go the other direction. So if I say find the surface area of a sphere, find the surface area of a sphere if I give you the volume. And here's the trick. No matter which way you go, when I'm moving from surface area to volume or vice versa, there's the relationship that I have in between that either way I need to find the radius. Finding the radius is the middleman. That's the key to everything. When you're asked to convert between volume and surface area, whichever way you're going, find the radius. That's it. So here we go. The volume of this sphere that I have is 2304 pi. Well, volume can be found by getting 4/3 pi r cubed. And I know that if I plugged in that number, if I plugged in the right radius, I get 2340 pi. Well, conveniently, we have a pi on both sides, so it goes away. And so I'm left with 4/3 of r cubed being equal to 2304. Okay, to get rid of the 4/3, let's multiply by 3/4. Because I know that 3/4 times 4/3, those go away. So I'm going to be left with r cubed is equal to 2304 times 3 divided by 4, 1728. Now, if you have the cube root button on your calculator like I have, it looks like a little square root sign with a little 3 up here. That's the cube root button. You can hit that now, or you can raise to the 1/3 power. So either way, I'll go ahead and do the raising to the 1/3 power. My radius is 12. Let's see, it looks like millimeters, right? So we're almost done now. The question was not find the radius, it was find the surface area. But now I can go through and do part 2. See, the surface area is 4 pi r squared, and now I know the radius is 12. So I just need to take my time, do order of operations. 4 pi, 12 squared is 144 units. Combine the 4 and the 144, and I get 576. The surface area is 576 pi square millimeters. All right, video is getting a little long, but I've only got one example left, so I'm going to work through it. One more. Let's work backwards from volume to surface area. Find the volume of a hemisphere. Ooh, that's going to be tricky, okay? It has a surface area of 300 pi square inches. So I've got this shape here, a hemisphere, and the surface area is 300 pi square inches. Well, I might recall, let's go back, let me pull this thing out one more time. The surface area of a hemisphere, I got 2 pi r squareds, half of the 4 pi r squareds for the curved surface, an extra pi r squared here, total of 3 pi r squareds. This looks like it's going to work out nice and easy, doesn't it? Surface area of that sphere is 3 pi r squared, and if I plug in the right value for r, I should get 300 pi. Well, conveniently, pi on both sides, it goes away, so I have 3 r squareds being equal to 300. Let's divide out the 3. So now I get the r squared is equal to 100, which means r is 10. The radius is 10 inches. Now it's time to go find the volume. Volume for a normal sphere is 4/3 pi r cubed. Because I have a half of a sphere, I only have 2/3 of a pi r cubed, right? So now I know that the radius is 10. I know I need to take 2/3 of pi times 10 cubed. Order of operation says I do this first. 10 times 10 times 10 goes first. That's 1,000. And then I have to multiply 1,000 times 2/3. And if I do that, it turns out that it's just 2,000 over 3. And I have a pi somewhere. You can put it in the fraction. You can put it after the fraction. I'll just throw it up here. Okay? If it goes off here at the end, it's okay. but that would be cubic inches. So there you go. There are some problems to help get you started. You should be able to do the homework now with a little help from me.